Good morning to all the participants of the value added course on renewable energy technology and its future potential. Welcome to module 2 of this course on wind energy. Today, we have Dr. Saima Beg as the presenter of the topic, and I, Dr. Piyush Sharan, will be the moderator of the program for the day. Wind power accounts to nearly 10% of India's total installed power generation capacity and generated 62.03 megawatt hours in the fiscal year 2018-19, which is nearly 4% of the total electricity generation. So we can see that wind energy has a huge potential in the renewable energy sector. It's time that we call upon Dr. Saima Beg to enlighten us on this topic with her presentation. So I invite Dr. Saima Beg, ma'am. Ma'am, please.
Okay, thank you, Piyush. And a very good morning to all of you. Today we are going to discuss about the value-added course that is renewable energy technology and its future potential, module 2, that is wind energy. So first of all, I would like to tell you about the what is wind. Okay, so wind is the stabilization movement of air pressure, between the areas of high and low atmospheric pressures that is created by the uneven heating of the Earth's surface, that is land, water, and air. The greater the pressure differences between these areas, the harder the wind blows. And the wind also exists as a circular of air around the high and low pressures areas. So, so wind is the stabilization movement of air between the high and low atmospheric pressure. Okay. First of all, I would like to discuss with you about the history of wind energy. So we see in the late 5000 BCs, sailboats were used on the Nile, indicated the power of wind. Then comes the 500 to 1900 ADs, where the first windmill was developed in Persia. And then in 1300 ADs, first horizontal axis windmill was developed in Europe. Then 1850s, Daniel Halland and John Barham built Halliday windmill that was started in US. And in late 1880s, Thomas O. Parry conducted 5,000 wind experiments. Okay. Then comes the 1888, where the Charles F. Brush used windmill to generate electricity in a Cleveland. Okay. Then in 1900, windmills was pumped salt water to evaporate ponds. Then comes the 1941, in where the Ganappa knob turbine supplies power to the small towns. And in 1979, first wind turbine rated over 1 megawatt began operating. Then in 1985, CA wind capacity exceeded to 1,000 megawatt. Then in 1993, US wind power developed first commercial variable speed wind turbine. And in 2004, electricity from the wind generation cost 3 to 4.5% per kilowatt hour. Then comes the 2013, where the wind power provided over 17% of the renewable energy used in US. Then in 2016, Block Island offshore wind farms was brought online. So this is the brief history about the wind energy. So wind energy is the converting of wind power to the electrical power through the use of windmills or turbines. That means the energy that is coming from the winds is converted into a wind power to electrical power through the use of windmills or turbines. That electricity produced is sent to the transformers, where the voltage is increased and sent to the power grid via transmission line. This is a brief working of wind energy, how the wind energy is going to be generated. Okay, so this electricity is sent to the transformers, where the voltage is increased and sent to the high power grids via transmission lines. So next see the wind power. The first use of large windmill to generate electricity was a system built in Cleveland, Ohio in 1888 by the Charles F. Brush. This brush machine was a post mill with a multiple bladed picket fence, rotor 17 meters in diameter, featuring a large tail hinge to turn the rotor out of the wind. It was the first windmill to incorporate a step-up gearbox in order to turn a direct current generator at its required operational speed, that is 500 rpm. So we see what is this windmill, wind power. Okay, all renewable energy except tidal and geothermal ultimately comes from the sun. The earth receives 1.74 into 10 to the power 17 watts of power per hour from the sun. About 1 to 2% of this energy is converted to wind energy, which is about 50 to 100 times more than the energy converted to biomass by all the plants on the earth. Differential heating of the Earth's surface and the atmosphere induces vertical and horizontal air currents that are affected by the Earth's rotation and contour of the Earth that creates the wind. Winds are influenced by the ground surface at altitudes up to meters, 100 meters. Wind is slowed by the surface roughness and when dealing with wind energy, we are concerned with the surface winds. A wind turbines obtain its power input by converting the force of wind into a torque acting on a rotor blades. The amount of energy which the wind transfers to the rotor depends upon the density of the air and the rotor area and the wind speed. This kinetic energy of the moving body is proportional to its mass. The kinetic energy of the wind thus depends upon the density of the air, that is the mass per unit volume. In other words, we can say the heavier the air, the more energy is received from the turbine. At 15 degrees Celsius, air weigh about 1.225 kg per cubic meter, but the density decreases slightly with increasing humidity. Now the question arises from what is this wind energy and where it comes from. So I already told you that this all renewable energy ultimately comes from the sun except the tidal and the geothermal power. The earth receives around 1.74 10 to the power 17 watts of power per hour from the sun. So next we will see the windmill design. What is this windmill design and what is this windmill? A windmill captures the wind energy. Windmill is a machine that is going to capture the wind energy and then uses a generator to convert it into the electrical energy. The design of windmill is an integral part of how efficient it will be. When designing a windmill, one must decide on the size of the turbine and the size of the generator. Windmill turbines can be categorized as large turbine and the small turbines. In case of large turbines delivers electricity at lower cost than smaller turbines because foundation cost, planning cost, etc. are independent of size. These large turbines are well suited for offshore wind power plants. In areas where it is difficult to find sites, one large turbine on a tall tower uses the wind energy extremely efficiently. Then the small turbines, windmill, local electrical grids may not be able to handle the large electrical output from the large turbine. So smaller turbines may be more suitable. And the high cost for foundation for large turbines may not be economical in some areas. That's why we are going to use these smaller turbines. Modern windmills, wind turbines. Commercial wind energy is one of the most economical source of new electricity available today. So these wind turbines can be set up quickly and cheaply compared with the building new coal-fired generating stations or hydroelectric facilities. So these modern wind generating equipment are more efficient, highly reliable, and becoming cheaper to purchase. The environmental impact of large wind turbines is negligible compared to an open pit coal mines or a reservoir, and during their operation produces no air pollutions. That is another benefit of using the wind turbines. Because of these factors, wind energy is is recognized as the world's fastest growing new energy source. To all of you, hello,
Yes, ma'am. आपकी आवाज
hello,
आ रही
hello.
है? Ma'am,
हाँ, Piyush.
you are audible. Please share your
Okay,
PPT, ma'am. Now
okay, okay,
there was some technical glitch because of the rains. Okay. Just share your PPT 1 second.
okay, okay. Is it fine? Am I audible and visible to all of you?
Yes, ma'am.
Okay,
Your PPT is
so
now visible. Can you move to modern wind turbine slide, ma'am?
okay, okay,
Yes,
yeah,
ma'am. You have finished this one. You can move to the next slide after this.
okay, okay, okay. Thank you, Piyush. So the wind turbines, first of all, we see the what how the wind turbines is going to work. So these wind turbines operate on a simple principle, like the energy of the winds turns two or three propeller-like blades around a rotor. And as you see from the picture, the rotor is connected to the main shaft, which spins a generator to create the electricity. Wind turbines are mounted on a tower to capture the most energy at 100 feet or 30 meters or above the ground. They can take the advantage of faster and less turbulent wind. Wind turbines can be used to produce electricity for a single home or buildings, or they can be connected to an electricity grid for more widespread electricity distribution. So these modern wind turbines can be categorized into two classes, that would be vertical axis turbines and the horizontal axis turbine. In the first picture, we see we are having a vertical axis turbine, and the second picture is of horizontal axis turbines. So from the picture, we already see that this vertical axis turbine is omnidirectional. That means it accepts the wind from any direction. So this is the advantage of this vertical axis turbine, that it accepts the wind from any direction. Okay, and these the components can be mounted at the ground level. That means it is easy to service. Because of the ground level, it is easy to service and lighter weight towers. Next advantage of this vertical axis turbine is that it can be theoretically use less materials to capture the same amount of wind. Obviously, everything that has advantage also having the disadvantages too. That means the disadvantage of these vertical axis turbines is rotor generally near the ground, that where the wind power is poorer, where the wind is poorer. Also, the centrifugal forces stresses blades and poor self-starting capabilities, and it also requires support at the top of the turbine rotor. It also requires the entire rotor to remove to replace the bearing. Okay, and the last is the poor performance and poor reliability of this vertical axis turbine. In the next picture, we are having the horizontal axis wind turbines. This horizontal axis wind turbines, in the first picture, we see that these type of horizontal axis turbines have been used in farms, homes, and remote applications like water pumping and telecom sites and ice making. Then the wind turbines that are having the intermediate power like 10 to 250 kilowatts, they can be used in village powers, hybrid system, and distributed systems. And the wind powers that are having the 250 kilowatts to 2 megawatts, these wind turbines can be used in central stations, wind farms, and distributed powers and schools. This is the wind turbine. Okay, we see that we are having the three shafts there, and the components A, B, C, and D. So the A component, A is these are the blades of the wind turbine. Okay, B is the hub, and C is the nacelle, and D is the tower. If we see the internal structure of this wind turbine, it will be like this. You can say, you can see how does the wind turbine works. So this is the internal structure of the wind turbine. So next we see how these different components are going to work. That means the first one, that will be your blades. Most turbines have 2 or 3 blades. Wind blows over the blades, causing the blades to lift and rotate. Okay, so these are the blades. Next is the brake, a disc brake, this one. A disc brake which can be applied mechanically, electrically, or hydraulically to stop the rotor in the emergencies. Okay. Next is the controller. Here is the controller. The controller, what is the function of controller? The controller starts up the machine at wind speed to about 8 to 16 miles per hour and shut off the machine at about 55 miles per hour. Turbines do not operate at wind speed about above 55 miles per hour because they might be damaged by the high winds. Okay. Next, we are having the gearbox, that the orange one. Okay, this gearbox connects the low speed shaft to the high speed shaft. That increases the rotational speed from about 30 to 60 rotational per minute to about 1000 to 1800 rotational per minute. The rotational speed required by the most generators to produce electricity. The gearbox is costly, part of the wind turbine, and engineers are exploring direct drive generators that operates at lower rotational speed and don't need these gearbox because of its cost. This is the generator, the blue one. Okay, usually an off-shelf induction generator that produces 60 cycles AC electricity. High speed shaft drives the generator. Low speed shaft, the rotor turns the lower speed shaft at about 30 to 60 rotational per minute. Next is the nacelle, this one. The nacelle slits atop the towers and contains the gearbox, low and high speed shaft generators, controller, the brake. Some nacelle are large enough for a helicopter to land on. Okay. Next is the pitch. These are the pits. The function of the pitch are is to turn the blades or pitched out the wind to control the rotor speed and keep the rotor from turning it wind that are too high or too low to produce electricity. Then comes the rotor. This one is the rotor. The function of the rotor, the blades and the hub together are called as the rotor. Okay, when the assembly that contains the blades and a hub together, we are having a rotor. Next comes the tower. The tower are made up of tubular sheets, concrete or steel lattice. Because the wind speed increases with height, taller towers enables turbines to capture more energy and generate more electricity. Then next is the wind direction. These wind direction of wind turbines so called because it operates facing the wind. Other wind turbines are designed to run downwind, facing away from the wind. Next is the wind vane. This is the wind vane. Measures wind direction and communicates with the yaw drive to orient the turbine properly with respect to the wind. We are having this yaw drive here. Yaw drive, this upwind the turbines face into the wind. This yaw drive is used to keep the rotor facing into the wind and keep the turbine moving smoothly. Also have a फिर गई
Ma'am, your presentation was fine. आप shit. Ma'am, you can now share the screen once again.
Okay,
उसी समय स्ट्रीम बंद हुआ था मैम बस जब
okay,
आप
okay,
सो यू हैवंट मिस्ड एनीथिंग ये
okay,
स्लाइड
okay. Thank
क्या
you.
आप उसी पे बता सकते हैं
So the wind turbines depends upon the number of blades. Most common design is the three-bladed turbines. Most of you see when the wind turbines are of having the three blades. The most important reason is the stability of the turbine. A rotor with an odd number of rotor blades can be considered. A rotor with an even number of blades will give stability problems for a machine with a stiff structure. The reason is that at very moment when the uppermost blade bends backward, because of it gets the maximum power from the wind, the lowermost blade passes into the wind shade in front of the tower. That's why we are going to use this odd number of blades in our wind turbines. These diagrams shows the wind turbines that are having the different number of blades. Most common design is a three-bladed turbine. The most important reason, again, the stability of the turbine. Okay, a rotor with with an even number of blades will gives the stability problems. Next important part of the wind turbine is the wind generator. Okay, the function, what will be the function of wind generator? Wind power generator converts the wind energy to electrical energy. Wind energy is a mechanical energy that is going to be converted into a electrical energy with the help of these generators. The generator is attached at one end to the wind turbine, which provides the mechanical energy. Okay, at the other end, the generator is connected to the electrical grid. So these generators needs to have a cooling system to make sure that there is no overheating should be there. This is the diagram that shows the movement of generator. Okay, wind power generators convert the wind energy, that is mechanical energy, to the electrical energy. The generator needs cooling system to avoid the overheating. Generators are of two types, small generators and large generators. Small generators requires lesser force to turn than the larger ones because gives much lower power output. These small generators are also less efficient. If you fit a large wind turbine rotor with a small generator, it will be producing electricity during many hours of the year, but it will capture only a small part of the energy content of the wind at high wind speeds. Whereas in case of large generators, these large generators are very efficient at high wind speeds and unable to turn at low wind speeds. That is, if the generators has larger coils or a stronger internal magnet, it will require more force to start in motion. These small generators require lesser force to turn than larger ones, but gives lower power output. That's why these are less efficient. Okay, and these large generators are very efficient at high wind speeds. If the generator has larger coils or a stronger internal magnet, it will require more force to start in motion. Other design considerations like winds are influenced by the ground surface at an altitudes up to the 100 meters. Wind is slowed by the surface roughness and any obstacles. When dealing with wind energy, we are concerned with wind surfaces. A wind turbine obtains its power input by converting the force of the wind into a torque, turning onto the rotor blades. The amount of energy which the wind transfers to the rotor depends upon the density of the air and the rotor area and the wind speed. That means the kinetic energy of the moving body is proportional to its mass or weight. The kinetic energy in the wind thus depends upon the density of the air, that is its mass per unit volume. In the other words, we can say the heavier the air, the more energy is received by the turbine. At a typical 600 kilowatt wind turbine has a rotor of diameter in meters, the rotor area of some 1500 square meters. The rotor area determines how much energy a wind turbine is able to harvest for a wind. To be considered a good location for wind energy, an area needs to be average annual wind speeds, often at least 12 miles per hour. Wind power builds so it is too severely interrupts the airflow. Through its cross section will reduce the effective wind velocity at its location and divert much of the airflow around itself, thus not extracting the maximum power of the wind. At the other extreme, a windmill that interrupts a small fraction of wind passing through its cross section will reduces the wind velocity by one of the small amount, thus extracting only a small fraction of power from the wind traversing the windmill disk. Modern windmills can attain an efficiency of about 60% of the theoretical maximum value. Okay, so next is the power of the wind. Power of the wind is proportional to the cubic wind speed. Okay, kinetic energy of the air mass proportional to V2 amount of air, that is amount of air mass moving past a given point is proportional to the wind velocity. This is a diagram that shows the wind farms where we see the wind turbines when when the blades are moving, shaft are energized, the wind turbines is working, and the power that are attained by the mechanical power that are attained by these wind turbines has been transferred to the transformers and finally sent to the transmission lines. Offshore wind farms. The first US offshore wind farm is Block Island Wind Farm, located off the coast of Rhode Island. This 5 turbine, 30 megawatt wind farm began operation in 2016. Then next is the cost of the wind turbine. A typical 600 kilowatt turbines cost about 4,50,000, and the installation costs are typically 1,25,000. Therefore, the total cost will be around $5,75,000. The average price for the large modern wind farms is around $1,000 per kilowatt electrical power installed. Modern wind turbines are designed to work for some around 1,20,000 hours of operation throughout their design lifetime of 20 hours. And the maintenance costs are about 1.5 to 2% of the original cost per year. Last, we are going to move on through the advantages of wind power. So there are different advantages of wind power. The wind blows day and night, which allows windmill to produce electricity throughout the day. Okay, because the wind is blowing through day and night, that means windmills are going to produce the electricity throughout the day. And the energy output from the wind turbines will vary as the wind varies, although the most rapid variations will to some extent to be compensated by the inertia of the wind turbine rotor. Wind energy is a domestic and renewable source of energy that generates no pollution and has a little environmental impact. Up to 95% of the land used for wind farms can be used for other profitable activities, including ranching, farming, and forestry. The decreasing cost of wind power and the growing interest in renewable energy sources should ensure that wind power will become a viable energy source in the United States and the worldwide. Then next is the disadvantages. The wind is not always predictable. Some days has no wind. Okay, that means suitable areas for wind farms are often near the coast, where the land is expensive. Some people feel the covering of landscape with these is unsightly. These windmills can kill birds also. Migrating flocks tends to like strong winds. However, this is rare, and we tend not to build wind farms on migratory routes anyway. These windmills can affect the television reception if you live nearby. These windmills can be noisy. Wind generators will have a reputation of making a constant noise, showing noise day and night, which can be drive you nuts. This wind is free. Wind farms need to be no fuel, purchase, no waste, or greenhouse gases. These are the advantages of this windmill. That wind is free. That means they requires no fuel, okay, and produces no waste. The land beneath can usually still be used for farming. The wind farms can be tourist attractions and this is also a good method of supplying energy to the remote areas. Continuing to the wind advantages of wind power, the wind blows day and night, this is already discussed, okay, and the energy output from the wind turbines may vary as the wind varies, although the most rapid variations will to the some extent be compensated by the inertia of the wind rotor. The decreasing cost of wind power and the growing interest in the renewable energy sources should ensure that the wind power will become a viable energy source in the United States and the worldwide. These are the some striking facts about the wind energy potential in the US. The US contains enough usable wind resources to produce more electricity than the nation currently uses. The majority of this uses resources is in the Great Plains region, that is North Dakota alone has enough suitable wind resources to supply about 36% of the electricity consumed in the US. In addition, the development of major global wind energy markets could significantly impact jobs. Recent studies shows that these billion kilowatt hours of annual wind energy generates creates between 440 to 460 jobs. I think this will be the enough for you to know about the wind energy, wind power. Okay, thank you so much. Any questions, any queries?
Thank you, ma'am. Ma'am, as I can see, there are no queries from student side. So
Okay,
we'll have to wind up the session here only. So
okay,
I really thank you, ma'am, for sparing your valuable time for this event, and you have indeed shared a very informative lecture about wind energy, and it has really great potential when it comes to coastal regions, not in exactly in UP, but other coastal areas where wind speed is higher and it can be easily harvested. That portion can be very useful for the learners of engineering students of solar photovoltaic and other renewable energy technologies. So thank you, ma'am. With
okay.
this, I would like to share one thing to the students, that you will be having a quiz that will be opened on ILI. You will have to mark your attendance. Is in case there is no attendance, it will be shared by the evening today, and you will have to mark your attendance for the day, and you have to attempt the assignments and all the activities available in the mood in this ILI LMS for module 1 and 2 both, and you will be given time up to 2nd of July. So thank you so much for sparing your time, ma'am.
Thank you, Dr. Piyush. Thank you so much.
Thank you, ma'am.